Hello, everyone, and welcome. My name is Liz Pimper, and I'll be your moderator for today's WJE webinar, the San Francisco Facade Ordinance, Planning, Logistics, Inspections, and Reporting. During the next hour, WJE experts Aaron Weiss and Chris Martinez will review the requirements of the Facade Ordinance, explore some common planning and logistical issues associated with performing the required inspections, and compare several strategies that can be used to reduce the cost of completing maintenance and repairs that may be required by the inspection report. This presentation is copyrighted by Weiss Janney Elstner Associates. And now I will turn it over to Chris to get us started. Chris?
Thank you, Liz. And thank you to everyone for joining Aaron and I today as we discuss the planning, the logistics, the inspections, and the reporting of the Building Facade Inspection and Maintenance Ordinance for the City of San Francisco, otherwise known as the San Francisco Facade Ordinance. So for today's learning objectives, by the end of the presentation, you will be able to describe the general inspection and reporting requirements, summarize the 3 potential building classifications assigned by the report, identify facade access challenges and limitations, and plan and budget for the initial inspection and report, as well as subsequent inspections and reports on a 10-year cycle. And just to give you a brief little outline, I will start us off by going over some background information that touches on some key points within the ordinance, as well as some references to building codes and standard documents. From there, I will hand it over to Aaron, where he will discuss the planning and logistics side of things, as this is the most important step when it comes to managing costs and reducing risk. Then Aaron will dive into the inspection process, where he will discuss basic requirements and compare several strategic approaches. And lastly, I will maneuver us through the reporting requirements for the inspection report, as well as touch on potential subsequent follow-up reporting to the city. Now, without further ado, let's get into the background. So the San Francisco Facade Ordinance became effective on June 5th, 2016. Its current iteration amends the San Francisco Existing Building Code, otherwise known as SFEBC, with the inclusion of Chapter 5F, which also requires the inspection and maintenance of facades for buildings meeting certain requirements. Now, I'd like to note that this is Chapter 5F of the 2019 SFEBC, as if you were to search the sfgov.org website, you will find that the San Francisco Facade Ordinance that they provide a link to is the original ordinance, which has not been updated. Oops, excuse me. Next up, we have the Administrative Bulletin 110, also known as AB 110, which was enacted after the San Francisco Facade Ordinance and generally details the inspection and reporting procedures that were previously referenced within the San Francisco Facade Ordinance. AB 110 is primarily based on and modifies the information within ASTM E2270-14, which serves as a standard practice for the periodic inspection of building facades for unsafe conditions. As AB 110 provides a more holistic view of the inspection requirements, it is important to look at ASTM E2270-14, as that really outlines the inspection requirements, as well as includes documentation and reporting procedures. I would also like to note that another reference, which is included in both the San Francisco Facade Ordinance and AB 110, is ASTM E2841-11, which serves as a standard guide for conducting inspections of building facades for unsafe conditions. With that being said, there is an updated 2019 version, but it is not yet referenced in AB 110. Now I'd like to point out that to provide further clarity, as well as just because it is easier to say, we will be referring to the conjunction of the San Francisco Facade Ordinance, the SFEBC Chapter 5F, and AB 110 as just the ordinance, unless we specifically want to draw your attention to a certain document. So what exactly is the intent of the ordinance? Well, the ordinance is intended to promote public safety and welfare, as well as to encourage inspection and repair of building facades. And while they aren't specifically goals of the ordinance, some added benefits are being able to reduce damage resulting from earthquakes, as well as being able to maintain and protect San Francisco's great historic treasures. I would also like to note the following important items. First, according to the ordinance, facades can be maintained and repaired to the applicable code in which they were constructed under. However, since construction techniques have advanced, as well as just general knowledge of vulnerable conditions, we believe that a reasonable upgrade can be completed if they are appropriate. Second, the ordinance should not be thought of as an end-all be-all when it comes to identifying facade deterioration. Yes, a more experienced inspector will be able to recognize more subtle conditions, but the procedures of the ordinance are not intended to identify the full 100 extent of damage. And third, the ordinance does not require code or seismic upgrades, which really can save the property owner a lot of money. Now, as I previously mentioned, one of the goals of the ordinance is to inspect facades. This inspection process can help identify unsafe conditions or conditions that could deteriorate into unsafe conditions. This is extremely important, as an unsafe condition could allow a portion of the facade to fall onto the adjacent property, or even worse, an unbeknownst bystander walking by. So which buildings are the ones that need to be considered as part of the ordinance? Well, buildings qualify if they have a height of 5 or more stories and if they are construction types 1 through 4, which means that construction type 5 buildings, or otherwise known as wood frame buildings, are not included. So with those parameters known, that estimates 3,700 qualifying buildings in San Francisco. However, with that being said, buildings of construction type 5 and buildings of heights less than 5 stories may voluntarily apply the provisions of the ordinance. Now, this wouldn't be San Francisco without its hills, and since hills cause sloping sites with various levels of grade around the building, determining what counts as a story for facade inspections can be pretty important. And while the ordinance does not define which stories are to be counted, the California Building Code, otherwise known as the CBC, does, and indicates that stories above the grade plane, which is an average of grade around the entire building perimeter, are counted. Additionally, the CBC also indicates that an intermediate level that is qualified as a mezzanine is not counted as a building story. So we know what the intent of the ordinance is and which buildings are to be inspected, but who does the actual inspection? Well, the ordinance indicates that a qualified professional is the person who will directly supervise the performance of the inspection and the reporting. And according to the ordinance, a qualified professional is a California licensed architect or engineer who is retained by the property owner. And for historic buildings, that qualified professional must also have experience with inspection, maintenance, and repair of historic resources, and is subject to the approval of the Department of Building Inspection. As such, a historical building's qualified professional needs to have a documented history of successful projects and detailed investigations in order to prepare treatment-appropriate recommendations. I would also like to note that we will be referring to these qualified professionals as AE inspectors. And for those of you wondering if all facades have to be inspected, the answer is yes. All exterior facades are required to be inspected, even those over adjacent roofs. And that also includes penthouses and chimneys, as well as former exterior facades, i.e. those that are now located in the interior of the building that have been converted from an exterior area by enclosing it under a roof, skylight, or some other covering. Now, it should be noted that those former exterior facades only need to be inspected once, or in other words, they only need to be inspected for the inspection cycle after it has been converted. From then on, it does not need to be inspected. Additionally, narrow courts that are smaller than 3 feet and courts on grade that are surrounded by walls, both with no door access, are exempt from inspections. With regards to buildings on federal property, they are not legally required to comply with state and local building codes. However, some agencies do emphasize that buildings should voluntarily comply with these local building codes to the maximum extent practicable. In addition to inspection by an AE inspector, with historic qualifications, maintenance, and repair work on historic buildings should conform to the requirement of the Secretary of Interior standards for the treatment of historic properties. In addition, the ordinance indicates that qualified historic resources may be evaluated using the provisions in the California Historical Building Code, so long as it results in acceptable performance as detailed in the SFEBC and AB 110. Now, before we continue with the presentation, I just wanted to give you a quick general idea of the entire inspection process just to get it into the back of your mind. As you can see, some key steps that happen even prior to the actual physical inspection are the document review and building engineer interview. The document review process consists of the AE inspector reviewing previous repair and maintenance documents, prior facade inspection reports, and existing building drawings, if available. The AE inspector also interviews the building engineer and reviews any known locations of water leakage or prior repairs. These preliminary steps are intended to identify potentially problematic areas to focus the later steps of the inspection. As for the physical inspection, there are 2 components. a general, more distant inspection, which typically consists of visual observation of the facade with or without magnification, and a detailed, more close-up inspection, which typically consists of visual observation where you're close enough to touch the facade. And I would like to note that ASTM E2270-14 indicates that 100% of facades should be included within the general inspection, while 25% of each facade should be included within the detailed inspection. And last but not least, after the inspection process is complete, the AE inspector prepares a report for the building owner who will submit it to the San Francisco Department of Building Inspection. But wait, there's one more. I briefly wanted to mention that although it is not part of the ordinance, the California Existing Building Code, or CEBC, mentions in section 302.2 that the code official shall have the authority to require the elimination of conditions deemed dangerous. The CEBC also defines the term dangerous as a condition on any building that is at significant risk of collapse, detachment, or dislodgement of any portion, member, appurtenance, or ornamentation of the building under service loads. So in other words, the code official can require building facade damage to be repaired. Now I will hand it over to Aaron so he can go over the planning and logistics side of things. Aaron?
Thank you, Chris. As Chris mentioned, planning and logistics are an important aspect of planning the initial facade inspection. The first step in preparing for a facade inspection is determining when the initial inspection report is due. The ordinance establishes 4 compliance tiers based on the construction completion date of a building. Each tier includes approximately 700 to 800 buildings, totaling an estimated 3,000 buildings to 7. The first tier for buildings constructed prior to 1910 have their initial inspection report due on December 31st of next year, 2021. Buildings constructed after 1997 have their initial inspection reports due 30 years after completion of construction. So buildings constructed in 1998 have reports due beginning in 2028. And all buildings require re-inspection on a 10-year cycle. Buildings that have recently conducted comprehensive inspection, repair, or restoration projects within the past 10 years can request a waiver for exemption from the initial inspection requirement. To request a waiver, the property owner would submit documentation of the recent project to be approved at the discretion of the building department for exemption from the initial inspection report. Buildings that experience significant damage or failure of facade elements, such as a piece of material falling from the facade, observation of severe damage or cracking, or have experienced a significant earthquake or other event, must have the damaged area inspected within 60 days. If unsafe conditions are encountered, they require immediate action, which will be discussed later. The beginning steps in planning for an inspection are gathering the necessary documents. Plans and elevations will be useful to the inspector in performing the inspections. They'll also need to review repair and maintenance records, as Chris mentioned. So gathering these documents up front will be helpful. The other big component in planning for an inspection is to plan the facade access, which includes 25% of each facade for the close-up inspection. Additionally, adjacent rooftops should be accessible, if possible, to perform the general inspection. And any facade access equipment should be certified in advance. Complex buildings can benefit from a pre-inspection evaluation. While not specifically required by the ordinance, a pre-inspection evaluation can identify access challenges and limitations early in the process. This evaluation can also estimate the overall conditions of the facade and anticipate locations where detailed inspections will be performed, possible investigation probes, which will be discussed later, and locations and types of likely repairs that may be needed. This pre-inspection evaluation can be performed as a separate site visit in advance of the general inspection or can coincide with the general inspection itself. This evaluation is generally of most value to a project when it's performed far in advance of the general inspection to get a good handle on the conditions that are likely to be encountered. Facade access is a critical aspect to successfully performing facade inspections. Conventional access typically includes suspended scaffolding or pipe scaffolding. Suspended scaffolding is the most common when used for facade inspections and can be a portable scaffolding system temporarily erected by a contractor or permanent facade access systems, often known as house rigs, that are permanently installed with equipment and hardware at the building for use in facade access, maintenance, and repair. Pipe scaffolding systems are not commonly used for inspections alone due to their cost of erection, and they're more common for large restoration and repair projects. Alternative means of access include aerial lifts, rope access, and crane baskets. Aerial lifts are often not allowed for routine maintenance on taller buildings. They also have significant limitations when used in dense urban environments, such as height and maneuvering requirements, support from underground and subterranean structures like sidewalk vaults, traffic control of pedestrian and vehicular traffic, and they can simply not access all areas of many buildings. Rope access is another alternative means of access that is commonly used for facade inspections, especially in other regions of the country. Stricter regulations regarding rope access in California do limit its use, but it has its place under special circumstances. Crane baskets are also a relatively uncommonly used means of access and are primarily useful in special circumstances, such as removing one or two loose pieces of material or accessing very limited portions of the facade. Rope access can be used for the detailed close-up inspection. Likely areas of damage are often in difficult to access locations on the facade, such as the tops of walls, the corners of buildings, and at complex architectural features like spires, turrets, fins, cornices, and tall parapets. Rope access can provide targeted inspections distributed around the building in an efficient manner. This is often appropriate at older buildings which lack modern facade access equipment or tieback anchorages and can be difficult to rig with suspended scaffolding. In California, rope access work requires special permission from Cal OSHA and can only be used when other methods are determined to be infeasible. Rooftop anchorages. Cal OSHA requirements state every building constructed 3 stories or 36 feet or more in height shall have roof tiebacks or other permanent devices. I'm not a facade expert, but I'm fortunate to work with one, and I consulted her regarding the requirements for rooftop anchorages on buildings in San Francisco. I asked her a number of questions about what is required and when, height limits, and such, and almost every answer was the regulations are complicated and it's not always clear. Ultimately, it depends on the building and a number of other factors. Generally, all buildings within the ordinance of 5 stories or higher are required to have roof tieback anchorages for facade access. There's a limited exception for buildings 4 stories or less, which doesn't apply to these buildings, or buildings that have other acceptable means, which is evaluated by Cal OSHA. Ultimately, property owners should consult with a facade access engineer to determine what the requirements for their building are. Rooftop anchorages facilitate window cleaning, routine maintenance, periodic facade inspection, and repair and restoration work. As I mentioned, they're required for almost all buildings that qualify for the ordinance, and the benefits of installing rooftop anchorages benefit the property owner and the building for the lifetime of the building, making these projects easier to perform and more likely to occur on a regular basis. Cal OSHA regulations also require that buildings 36 feet or more in height require an operating procedures outline sheet, or an OPOS. The OPOS describes the methods and configuration to set up scaffolding and other access means at a building to perform routine activities, which are defined as occurring 4 times within a year. Window washing is the most commonly performed activity within this category, and the requirement for an OPOS does not specifically apply to facade inspection and repair work because it's not routine. Having an OPOS and using it benefits the facade inspection process by establishing facade access procedures that can be used for the inspection. Older buildings may have alternative methods grandfathered into their OPOS that would no longer be allowed. So when planning for the facade access component of an inspection, consider installing rooftop anchorages or facade access systems in advance of the inspection to facilitate access. For existing systems that already exist, make sure you test and certify them in advance to avoid delays. Additionally, consider coordinating inspection and repair projects to use the access efficiently, and consult experienced facade contractors to determine the most appropriate method for scaffolding and access and estimated cost for budgeting purposes. Now I'm going to discuss two general approaches for compliance with the Facade Ordinance that each have unique advantages and disadvantages. The first approach, concurrent repairs, attempts to identify and quantify repairs during the general inspection process, design repairs after that, and then engage a contractor to provide facade access and perform repairs, while the detailed inspection is then also performed using the same access. The advantages of this approach is that it reduces the total cost and the follow-up requirements that may be required by the city. You're only going to pay for the access once, and you're going to complete the repairs so that follow-up repairs and documentation are not required. Most importantly, this approach reduces risk by repairing things as soon as they're discovered and not deferring them for later work. Disadvantages of this approach are that the upfront cost is increased because you pay for access, inspection, and repairs all at once. The upfront cost is also somewhat uncertain and can change as access is provided and repair quantities are refined. Additional items may be discovered that would need to be added to the project. This approach can also increase the schedule as you need additional time to evaluate and design repairs as well as to complete them during the detailed inspection process. A second approach is to perform a facade inspection only. This approach inspects required areas quickly using suspended scaffolding or rope access typically, submits the report, and then plans to complete repairs as required by the report timeline. Advantages of this approach are that the upfront cost is reduced as you're only paying for the limited access to the inspection areas and the inspection itself. This approach obviously can also reduce the schedule by eliminating the need to design repairs and install them. And it also can utilize rope access for difficult access conditions. As rope access does not typically repairs and investigation probes are not commonly performed from rope access, so it's generally limited to an inspection-only approach. Disadvantages of the inspection-only approach include that the total cost of inspection and performing repairs is increased because access must be provided multiple times. This approach also has the potential for follow-up repairs and documentation to be required by the city, and ultimately, risk is not reduced. Items that are identified and requiring repair will remain hazards until the repairs are completed. Now, to compare these two approaches in a little more detail. The concurrent repairs need extra time. You need time to identify conditions during a pre-inspection evaluation or during the general inspection, time to design repairs, likely producing construction documents for bid, and extra time once access is provided to install repairs. This approach can be applied to many different buildings and situations. For example, if the building needs localized repairs, maybe it has damage at one corner or in one discrete location, performing those repairs concurrently with the inspection is a very efficient approach. You won't need to re-access that area to repair those for the foreseeable future. Another scenario where this can be very appropriate is removing loose material. If a building has a lot of loose material, a basic inspection may not provide the opportunity to remove it all, but expanding access to remove all of the loose material can satisfy the interim mitigation of these hazards, even if they're not the full permanent repair. And then finally, the other end of the spectrum would be a full facade restoration, a building with significant deteriorated conditions at the facade that's in need of a full facade restoration. This might be better titled as performing the inspection concurrently with the repairs because the facade restoration project would be the primary project and the inspection would be tacked onto that to share the access. The second approach, inspection only, is certainly easier to plan and budget. It has a more defined timeline and cost. And additional inspection investigation probes may be required to design repairs. So satisfying the requirements of the inspection report alone may not be enough to eventually design repairs. So examples of where this approach would be appropriate is if there's limited schedule, limited time, if you're up against the deadline, you might not have time to design and install repairs, or if you have limited funds and you can't afford the full restoration project. or if you know that there's a future repair or restoration project that you're planning and budgeting for, and you simply need to satisfy the inspection requirements at this time before the full restoration project occurs. So looking at schedule a little bit, of course, every schedule is different and every project is different, and there's many variables that play into that. But I explored this idealized schedule for a small, simple building with average access requirements. The schedule is based on the assumption of one suspended scaffolding drop at each facade for a total of 4. This attempts to establish the absolute minimum amount of time that would be required, and obviously delays and other complications can extend schedules indefinitely. This proposed schedule here may even be a little unrealistic. While it accounts for some limited AE and contractor availability, it doesn't account for all potential delays and other complications, access complications and delays, weather, and other issues that may arise. Larger buildings also will require significantly more time for the detailed inspection portion, which depends on how the building is accessed, rigging, how the platforms are moved, and lots of other building-specific details. The detailed inspection at a very large building could take 4 to 6 weeks compared to the 2 weeks used in this schedule here. So I don't know that I would budget for any less than 7 weeks for a small, simple building facade inspection only. And for a larger building, it could take 8 to 12 weeks as a minimum. Some common issues with schedule that can cause delays. Contracts. Working out and negotiating contracts can simply delay the start of the project. Facade access is a very common cause of delays. Challenging conditions may arise, unanticipated situations, and equipment certification is a common source of delays. Showing up to a building to find out that the facade access equipment certification has lapsed and it needs to be re-inspected and certified. The AE inspector and contractors may have limited availability, especially approaching the deadlines, as a rush to complete these inspections come in. There's over 700 buildings that need to be inspected by next December, and we've only seen a few facade inspection projects completed to date. Discovery of unsafe conditions can also delay a project, causing initial or immediate action, which is discussed later, which can derail a project and cause delays after it's started. And then the need or decision to design and construct repairs obviously can extend the schedule, and it may even come up partway through the project and could cause unanticipated delays. So some means in which you can control schedule on these projects. Plan with an AE and a contractor in advance of the project. This will identify potential problems and complications and sort out things in the planning stage rather than while things are being executed. To install and certify rooftop anchorages and facade access systems. If you don't have these on your building, consider installing them in advance of the inspection, which will facilitate a quicker and more efficient inspection. If you do have these, make sure they're certified and ready for use. If schedule is a critical component of a particular project, you could consider using multiple suspended scaffolding setups. This would allow you to set up multiple scaffoldings at once and perform drops simultaneously, or to reposition the scaffolding on alternate days so the drops can be performed every single day on consecutive days. And then using rope access where appropriate can also reduce the schedule by performing just the inspection portion in an efficient manner, often in just a few days. Now I'm going to talk about the specific requirements for performing the facade inspection itself. As Chris mentioned, one of the first steps of performing the inspection is establishing the building's service history. This is done by reviewing documents, including permit records, repair and maintenance records, and previous facade inspection reports. These are to become familiar with the building's maintenance and repair history to understand areas of the building where the exterior facade inspection should be focused. Additionally, construction documents are reviewed to become familiar with the general construction of the building facade. The AE inspector also conducts an interview with the building engineer to identify any known locations of leakage or past repairs that should also be focused on with the exterior inspections. The inspection scope covers basically everything attached to the facade or part of the facade, including walls, windows, balconies, fire escapes, cornices, parapets, trim and ornamentation, attached equipment and ductwork, signs, air conditioners, The last bullet here really sums it up as any elements that could pose a safety hazard if dislodged. The San Francisco Existing Building Code, Section 502F, states, a condition of a building that poses an imminent hazard to a person or property is considered an unsafe condition. This definition differs from the San Francisco Building Code definition for unsafe, and AB 110, as part of the ordinance, requires immediate action, which will be discussed later. If unsafe conditions are identified by the AE inspector, they immediately report these conditions to the property owner and the San Francisco Department of Building Inspection. The AE inspector also prepares a mitigation plan. Here's the contact info for the Department of Building Inspection, and it should be noted that contact must be made by both telephone and written notice. When notified of unsafe conditions at a property, the property owner must take action to protect the public and property as soon as reasonably possible. They must also submit the mitigation plan prepared by the AE inspector and an implementation schedule to the Department of Building Inspection within 72 hours. Action to protect the public and property could include erection of scaffolding protection over a sidewalk, fencing or barriers to limit access to a hazardous area, removal of loose material to temporarily mitigate the hazard, or installation of netting or other protection methods. Now to the inspection itself. The general inspection is a visual inspection typically performed with binoculars, spotting scopes, and telephoto cameras, and visually without magnification. It's intended to include 100% of all exterior facades and is typically performed from street level, from adjacent rooftops, fire escapes, and other accessible areas of the building. The Facade Ordinance specifically notes remote sensing techniques that may be allowed on a case-by-case basis with department approval. These technologies include 3D surveys, remote aerial vehicles or drones, and other non-traditional methods. Drones are especially useful for performing facade inspections and are most applicable to facades that are difficult to view from the ground or from adjacent roofs. Drones are difficult to operate over urban sidewalks, and they're best suited for facades over adjacent roofs. They may also be helpful in developing more accurate repair drawings during the investigation phase. They are not a substitute for the detailed inspection requirements, which require the inspector to be close enough to the building to touch. The detailed inspection is both visual and tactile, so drones do not satisfy this requirement. Detailed inspections must include 25% of each facade and are focused in areas with a high risk to persons or property, areas with observed or suspected distress, or areas with possible concealed damage. So the locations of the detailed inspection will be based on the findings of the general inspection in areas where damage has been noted or is suspected. AB 110 and ASTM E2270 describe components of a detailed inspection. The inspector should evaluate horizontal ledges that can collect water and deteriorate materials. They should visually scan surfaces for out-of-plane displacement or dislodged materials. They should evaluate areas of staining, spalling, and water damage for the degree of deterioration and damage. They should acoustic hammer sound concrete and masonry surfaces to identify loose material and locate concealed damage. And they should evaluate the stability of facade items by pushing and pulling on them. Finally, they should remove any loose items if this can be done safely during the inspection process. Investigation probes are also a component of a facade ordinance inspection. Up to 3 investigation probes at each facade are recommended, or actually they're required by ASTM E2270, but the ordinance clarifies that these are not required for San Francisco facade ordinance inspections. They are optional at the AE inspector's discretion based on observed conditions, and they're intended to evaluate concealed conditions that may contain concealed damage. The decision to make these optional was intended to avoid unnecessary probes and patches on buildings in the city. And while probes may not be required for compliance with the facade inspection, they may be of value for future repair design and could be done anyway. And as I mentioned before, The 3 probes potentially required by the inspection may not be enough to design future repairs, and additional probes may be required in order to gain the information necessary to design future repairs. And the types of deterioration and damage that the inspector is looking for. These are commonly found on building facades. Cracks and spalls occur in different materials, including concrete, brick, terracotta, and stone. They're caused by a variety of different mechanisms, and understanding what caused the crack is critical in order to design a sufficient repair. Corrosion is also a common issue with building facades. On older buildings, there's often embedded metal within masonry facades, which can cause cracking in some circumstances. And on newer buildings, this will often be metal window and cladding components that may be corroding, including their anchorages to the building. Mortar joints and sealant joints also require regular maintenance and are common sources of water leakage, and any areas with water stains may indicate potential concealed damage or deterioration. The quality and value of a facade inspection depends on the experience level of the AE inspector. Detailed inspections focus on observed or concealed damage. And while the inspector should focus on these areas, it can increase the inspection cost, especially the access costs to access these difficult areas, and it may also increase the amount of required repairs included in the report. If they look harder, they may find more damage. This identifies risks, which is the first step in reducing these risks. Whether the repairs are implemented right away or deferred, at least the risks become identified and known. An experienced AE inspector, backed by broad experience within their firm, can diagnose the causes of damage and distress. Not all cracks are the same, and not all cracks are caused by the same mechanisms. Understanding why and how a crack occurred is necessary in order to repair it. Using investigation probes selectively only as needed, and recognizing when additional probes may be of value for future repair designs. And finally, a good AE inspector can anticipate and plan for rational repair concepts appropriate to the building. And now I'll hand things back over to Chris to discuss the details of the reporting requirements for the Facade Ordinance.
Thanks, Aaron. Now let's discuss the reporting requirements. So for starters, the report should include basic property information, such as location, date of original construction, and historic status of the building, just to name a few. In addition, the report should also include some detailed descriptions of the building, which will include the construction type, the material used for exterior construction, the number of stories, and any other relevant information that might be beneficial. With respect to document review, the report should list which documents were reviewed by the AE inspector as part of the inspection, which can include other previous reports or even building permits. Now, visually speaking, as the adage goes, a picture is worth 1,000 words. So photos of each elevation showing general existing conditions are also required. Also, it is important to recall that ASTM E2270-14 was used as the basis when creating AB 110. And typically speaking, most of the standard practice included within ASTM E2270-14 is required for compliance with the ordinance. However, with that being said, ASTM E2270-14 requires the inclusion of detailed floor plans, construction details, and other detailed documentation, like elevation drawings. But the ordinance indicates that those drawings or documents are only required as necessary to undertake the inspection or communicate inspection findings. It is also important to note that ASTM E2270-14 allows the use of digital photography that has been perspective corrected for drawing development, so long as there is a clear depiction of the facade. Now, as this is a report about the inspection of the facade, included within the report are the AE inspector's findings, observations, recommendations, and conclusions. So the AE inspector is required to include descriptions and photos of the deterioration that was observed and noted, as well as indicate the likely cause of the deterioration. Additionally, the ordinance requires the AE inspector to recommend repairs. However, we interpret this to mean conceptual repairs rather than repairs that have been fully developed. And with those repair recommendations comes an associated timeline for implementing them, along with any general maintenance recommendations. Now, it is important to note that photographic documentation of deteriorated areas with recommended repairs is not required if the report conclusion is ordinary maintenance, which I will touch on in a little bit. So according to the ordinance, each inspection report needs to assign a building to one of three conclusion categories. Those three categories are repair/stabilization following temporary mitigation of unsafe conditions, labeled Category 1, requires repair, stabilization, and maintenance, labeled Category 2, and ordinary maintenance, labeled Category 3. If a building is assigned to Category 1, then the building has one or more deteriorated conditions that the AE inspector has determined are unsafe. By this point, the owner will have implemented temporary mitigation measures, but further mitigation or repair may also be required or even completed. Also, all unsafe conditions should be identified within the report, even if they are previously mitigated or repaired. And in typical fashion, the report will include other conditions that require repair, stabilization, or maintenance in order to prevent those conditions from deteriorating into an unsafe condition before the required inspection in 10 years. Next up, if a building is assigned to Category 2, then the building has exhibited deterioration that, if not repaired, stabilized, or maintained, could progress into an unsafe condition before the next required inspection in 10 years. Similar to Category 1, the report also identifies other building elements that require repair, stabilization, and maintenance to be included before the next required inspection. Lastly, if a building is assigned to Category 3, then ongoing general repairs and maintenance are required, and the report shall make recommendations for the repair and maintenance of those items. So as the previous slide indicated, Categories 1 and 2 require a greater amount of repair work than Category 3, meaning that there is a possibility that the San Francisco Department of Building Inspection will require submission of follow-up documentation to demonstrate compliance. Now, with regards to the actual report submission, the property owner will be sent a copy of the report by the AE inspector upon completion. From there, the property owner or owner's agent will submit a copy of the report to the San Francisco Department of Building Inspection before the previously mentioned inspection report due date. Also included will be the affidavit signed by the owner, which will be used to affirm timelines and other requirements for submittal of additional report information, facade repair and maintenance, and other actions. As you can see on the slide, we have included both the email and physical addresses where the report needs to be sent to. And just to clarify, the report does not need to be sent to both. It can be sent to either or. So once the San Francisco Department of Building Inspection has received the report from the property owner or their agent, the department staff has 60 days to review the report and notify both the property owner and the AE inspector of confirmation that the report and the affidavit was received, indication whether the report is acceptable or needs to be revised, and confirmation of dates for subsequent required inspections. Lastly, it is important to note that all reports are to become permanent records of the San Francisco Department of Building Inspection, where they will be accessible to the public through a maintained database. The following table was taken from the San Francisco Department of Building Inspection's website and indicates the hourly rates for staff to review and process the facade inspection reports. These rates provide a general idea of what you can expect for costs, but the overall fees will vary based on the length and complexity of each individual report. Now, with regards to noncompliance, the ordinance specifically references SFBC Section 102A, which indicates that a building official can come out to inspect the building, issue a notice of municipal code violations, which has a set deadline to abate the violations, and even order the building to become vacant with limited entry, if they deem a serious and imminent hazard. Additionally, the building owner can expect fees associated with any work that is done by the building official charged at their hourly rate. Now, as we are close to the end, I would like to show you a couple of slides with some key takeaways. So if you haven't been paying attention, now would be a good time to start. So firstly, buildings of 5 or more stories and of construction types 1 through 4 are required to have their facades inspected. Each inspected building will have an associated report that is due on a date that is based off of the building's completed construction date. And a qualified professional who oversees the inspection and reporting must be a California licensed architect or engineer that is hired by the property owner. And so before the physical inspection process begins, the AE inspector must prepare by reviewing documents, identifying access challenges, and assessing the general conditions to identify locations of interest. Additionally, they will plan an inspection approach to ensure that they will meet the appropriate inspection requirements. Then comes the actual physical facade inspection, where the AE inspector will be looking at exterior facade elements to identify those that could pose a safety hazard if dislodged, as well as any unsafe conditions. To do this, they will perform a general distant inspection of 100% of the facades, then will follow up with a detailed close-up inspection of 25% of each facade. Additionally, the AE inspector can elect to use probes to evaluate concealed conditions within the wall assembly. After the inspection comes the reporting. Here, the AE inspector includes any findings and conclusions within a written report with supporting photographs. The report assigns the building a conclusion category and includes recommendations for general maintenance and typical repairs, along with a schedule for those. The report is then provided to the building owner, who submits it to the San Francisco Department of Building Inspection. Lastly, we have what happens after the report is submitted. Assuming the report is accepted by the San Francisco Department of Building Inspection, the design and installation of repairs, as well as performance of general maintenance, should be performed according to the timeline recommended in the report. The San Francisco Department of Building Inspection will likely indicate any follow-up inspection and documentation requirements for areas of the building where repairs are recommended. Oh, and as a reminder, that whole process will be repeated every 10 years. Well, now that we have gone through and you have a better understanding of the San Francisco Facade Ordinance, we would like to open it up to any questions that you may have.
All right. Thank you, Chris, and thank you, Aaron. As a reminder, if you have a question, please type it into the Q&A box and hit submit. And if we don't get to your question during the call, either Aaron or Chris will follow up with you afterwards. All right, let's take our first question. Who decides when repairs must be completed by?
Yeah, I can answer that. So it is a combination of both the AE inspector and the San Francisco Department of Building Inspection, since the AE inspector is the one who recommends the timeline of repairs and includes that with the submitted report. But the San Francisco Department of Building Inspection is the one who approves the timeline. So if they indicate that a revision in the report needs to be made and that affects the timeline, then it will go back to the AE inspector's court for them to make the adjustment. Also, as a little sidebar, any revisions or adjustments that are made to the report should be clearly noted when it is resubmitted.
Okay. Our next question. Does the ordinance require that ancillary aspects of the facade, such as damage to fire resistance or floor-to-floor fire safing, be reported or corrected?
I can take that one. The facade ordinance does not specifically address damage to fire resistance or fire safing. It is primarily focused on structural support of facade components and the potential for them to fall and cause injury or damage.
Okay. Our next question. You did a restoration for us, which was completed in early 2017. Can that work be used to meet the reporting requirements?
I'll take that one as well. Ultimately, the San Francisco Department of Building Inspection would determine if that work was qualified for the exemption from the initial reporting requirement, which would be dependent on the submission of documentation describing the extent and nature of the project. So it likely would qualify, but it would not be determined until the department reviewed the documents.
Okay, next question. Is there a way to see if our building has a report already on file with the city?
Yeah, I can take that one. So if you check with the city's website, they do have a database. So at least contacting them would be one way, or you can check their actual website to see if the database is easily accessible. I have not personally been able to check to see where the database is at, but if they do have a file on record, it would be there.
Okay, the next question. How much do facade inspections cost?
I'll take that. Obviously, cost is going to vary widely based on a number of factors, one of the biggest ones being the facade access component. Different buildings have different challenges, limitations, permanently installed equipment, and such. Just as a sort of budgeting exercise, the 7-week schedule for a simple, small, relatively straightforward building, I would estimate the AE inspector and contractor combined total cost to start around $40,000 to $45,000. And obviously, larger and more complicated projects would go up from there, just as a rough budgeting point.
Okay, the next question. Is there a follow-up inspection to the required repair work?
I can take that. As of right now, the ordinance doesn't clearly state whether there is, but it's our assumption that the city will likely require a follow-up inspection to review the repairs that have been completed, especially considering that as we interpret the repair documents to be more conceptual in the report, and getting a permit will require additional inspection for that.
Okay, our next question. Besides Cal OSHA, are there any other local bodies that govern regulations or requirements for access like suspended scaffolding?
I'll take that. And as I mentioned, I'm not a facade access expert or engineer, and a facade access engineer should be consulted when designing and installing permanent facade access equipment and anchorages. But my understanding is that Cal OSHA is the primary governing body, combined with the state and local building codes have additional requirements for some of the permanent installed equipment. But for something like temporary construction scaffolding, Cal OSHA would be the governing body.
Okay. Is it true that a building completed in 2000 won't need to perform its first inspection until 2030?
I can take that. Yes, I mean, the ordinance indicates that for after 1997 and the years preceding, it becomes every 30 years. So for those projects that have been completed in construction in 2000, it will be 2030 for the inspections to actually occur.
Okay, next question. What permits would be required for investigation probes for a landmark building? Would a C of A or a permit to alter be required?
I'm not sure exactly the answer to that. I would have to consult the building department.
Okay, next question. If federal buildings are not technically subject to the state and local laws, is submission of the facade reports to SFDBI voluntary?
Yes, they are voluntary, and it of course is dependent on the specific agencies that the federal buildings are associated with, but they are voluntarily.
Okay. Do UC buildings fall under the ordinance?
I'll take this. Well, I'm not sure specifically about UC buildings. I expect that they would, as state-owned buildings, would be required to comply with the state building code and local amendments, which includes the ordinance. So I do expect those would qualify.
Okay. Next question. What safety or training certifications are required for AE inspectors prior to accessing a facade via rope access, crane baskets, etc.?
I can take that. There's various rope access certifications that can be achieved, SPRAT and IRATA being the two big ones, but I don't believe that they're technically required to perform rope access work, although adequate training and supervision by qualified professionals is required, and that there's some internal requirements for firms that perform that work that govern their own training. Crane baskets, I'm not sure of. I think it's primarily permitting and permission. And then operation by a contractor, and the AE inspector would primarily be along for the ride.
Okay. So that's all the questions that we've received so far. So I think we'll just go ahead and wrap it up here a couple minutes early. If you have any lingering questions or think of anything after the call, of course, please reach out to either Aaron or Chris. Their contact information is here on the screen and is also in the speaker bios to the left of the presentation view. Thank you so much for joining us. We hope it's been educational. As a reminder, you'll receive an email this afternoon that will include a link to an on-demand version of this webinar that you can use to rewatch the presentation at your convenience or share with any colleagues who weren't able to join us live today. And that email will also include a link to access related resources, including a PDF copy of the presentation, as well as a link to download your certificate of participation. And finally, the teal icon at the bottom of your screen will open a very brief survey about today's webinar, which will also include an opportunity for you to suggest future WJE webinar topics. All feedback is welcome. We'd really appreciate if you'd take a few minutes to fill out that survey. And again, if you have any questions about WJE webinars, please don't hesitate to reach out to me, Liz Pemper, at lpemper@wje.com. So again, thank you for your time, and we hope you have a great rest of the day.